2.7 ya shabab, by the way, there is nothing new here. In this section, what is new is only the definition of the derivative. So we will see in this section mainly what is the derivative and what is the rates of change. The tangents in general, we have studied them before, the velocities, the derivative of the function, and the rates of change, what they are can consider as a new concept. So you have, if you remember, ya shabab, from 2.1, that we have defined the tangent of the curve at specific point to be the limit of this difference quotient. The value of the function at x minus the value of the function at a over x minus a, when x goes to a. You can write this, of course, the limit exists. If the limit exists, we have slope. If the limit does not exist, there is no slope. And you can write this one, by the way. Okay, this is also important. So if you have a curve at a specific point, that the slope of the tangent is the slope of the curve at that point. So if we ask you to find the slope of the curve at that point, or the slope of the tangent to the curve, it is the same, because you know at this point they are the same. The curve is like a line if you zoom it in or out. So the slope of this tangent line is the same as the slope of that curve at that point. This point, it is x and y. What is x? X is a. This is x. And the y is f of a. So it is the point here, it is f, it is a and f of a. There is another way to write this limit. You can write it this way. And this is also, you have seen this before in Math 001. It is the difference quotient. How to obtain this from here? It is so easy. Just put x minus a equals to h. So if x minus a equals to h, when x goes to a, what will happen here? H will goes to where? If x goes to a, h will goes to what? To 0. Here it is. And of course, what will be x? This x. X will be, you will move a to the other side, it will be a plus h. So this is x will be this one, a plus h. F of a is the same. So you can use this way or this way. I prefer this way, shabab, and you can notice that it will be much easier to use this. If you can, in some situations, you have to do this. Let's see the first example. So now the slope of the tangent line, you can find it this way or this way. And we will see later that this is just the derivative. We will study that in chapter 3, inshallah, with details. Now find an equation of the tangent line for this parabola at this point. So now what we have here, what is f of x? We need to apply these formulas. So f of x, it is x squared. F of x, it is x squared. And what is a, our point? It is 1. What is f of a? This is a, this is f of a. So f of a is 1. Now, what is the equation of the tangent line, shabab? Do you remember the slope intercept form or the slope point form? Y minus y1 equals to m times x minus x1. You have the point x1 and y1. Here it is 1 and 1. So this will be 1 and this will be 1. What we need to find here is just the slope. What is the slope of the curve at this point? When we study the derivatives later, the derivatives will be what? The derivative of this one, or let's call it y prime, what will be the derivative will be 2x. What x equals to 1? At 1, the y prime at 1, y prime at x equals 1 will be 2 times 1, it will be 2. So you will come here and put here 2. It will be very, very easy question, okay? But after studying the rules, the laws of the derivatives, the techniques of the differentiation. Now, until now, we don't have these rules, and we have it from our experience, from your high school or whatever. So now, what we will do we will do this definition or this definition. These are the tools that we have. So now, you will calculate it as a limit. The slope now, and this is if you have written quiz. But if you have multiple choice, like the quiz next class or on Thursday or Sunday, you can use whatever the method you want. Just you need to make sure that it is the right one. It is correct. So now what you will do as I said for you, you will just substitute. This is f of x, this is f at 1, this is x minus 1. Now it is a limit. You know how to do this. 2.3. How to calculate this limit? Factor, cancel, substitute. That's it. And it should be the same answer, by the way. You can check your answer using the derivatives. And as I said, this here it is. You can simplify at the end. This will be the equation of the tangent line. Find the equation of the tangent line to this hyperbola. It is not indeed exactly hyperbola. It's okay. So it is hyperbolic shape at this point. Okay. So what is f of x? Again, you need to ask yourself, what is f of x? What is a? A is 3. What is f of a? It is 1 here. Now you will substitute. طبعا you can use this way or the another way. Let me use this way. Limit f of x minus f of a over x minus a when x goes to a. So a is 3. So this will be 3 equals to limit when x goes to 3. F of x, it is 3 over x minus f of 3 is what? 1 over x minus 3. Now it is a limit problem. How to find this limit? Of course, it will be 3, the limit. Don't forget the limit unless you evaluate. So this is also one common mistake that some of you they are doing. Now simplify here. It will be 3 minus x over x. And this x, bring it down. So it will be x times x minus 3. This equals to the limit when x goes to 3. Now you can cancel this with this, but with negative 1. So you will have x in the denominator. This will be cancelled with this, and you'll have here negative 1. And of course, this will be negative 1 over 3. You can substitute. And this is so easy using this one. I think he solved it by using the another formula, and this is good for you also to practice both. But you can notice that this will be much easier, this one. Now what you will do, you will just apply a. This is a, and when h goes to 0. Now it is the same. You will have the same answer. Now you, instead of x, put plus h. So it will be 3 over 3 plus h minus 1 over h. The one, the value of the function h. Now do the same as I did here. Make this one a single fraction, then simplify. So he make it as a single fraction. Now this will be in the denominator. Now cancel h with h. You have negative 3. When h goes to 0, this will be 0. It will be negative 1 over 3. And it is the same. So this means, of course, now you will just substitute. This is the slope. This is the point 3. And this is 1. Simplify. This is the equation of the line that you are looking for. Again, I said using the derivatives, it will be much easier. Find the y prime. What will be y prime here? Who knows what will be y prime? You can do it later, Shabab.
Minus 3 to the power x minus 2.
Yes, it will be negative 3 over times or negative 3 over x squared. Okay, and you can substitute. The velocities now, how it is related to what we are talking about now. Also, this is 2.1. If you remember, we have mentioned there the position problem, the distance problem, and the tangent problem. So if you have an object or a particle that moves from a point to another point, so let's say that this is the time when the time is 0. So there is nothing here, the initial time. So when we let's say after certain time, after t equals a, like t equals 2, 3, whatever. And also, if you measure the velocity after another certain time, like here, if this is 3, this is 5, for example, and you can average now. If you can measure it here and measure it here, you can take the average to know what will be the velocity here in between. So this is the position at t equals a. This is the position after a plus h. And of course, now if f is the position function, then the difference f of a plus h minus f of a, which is the numerator of the expression that we have before, it is the change of position. So you know that the velocity, the usual velocity, of course, if we don't have a change on linear velocity, it is the distance over time. If you have displacement, it is displacement over time, and it will be the change of the position over h. This will be the average if you want to find the average. When you have the two velocities and you need to average them, this is the idea. If you, of course, have the position function. Now, this is what is called the average velocity, okay? But if you want to evaluate it exactly at this point, or at this point, or any point here, exactly. So what is it exactly? So what is the value of the velocity at A, for example? What you will do, you will take the limit of this average velocity. So this is why they call it an instantaneous velocity. The instantaneous velocity, it is just the limit of this difference coefficient, which is the same as the slope that we have defined before, but the difference here, the function here, it is the position function. So when we have a limit, it is the velocity or the instantaneous velocity. And without limit, it is called the average velocity. Let's take an example about this. Let me give you, do we have time? Unfortunately, no, we don't. I will give you another question. If a ball, so think about it with me, Shabab. If a ball is throwing into the air, so this is the ground, and there is a ball that has been thrown up. So at the beginning, the time it was 0, the velocity it was 0, everything it was at the beginning 0, let's say. So if a ball is showing into the air with its height in meters given by this function. So this function, it is for the height. So what is this? This is the position function. So this is the position function that we are talking about, because the height now is the position. So it is a function of time, because the height will be changed with time, of course. So this is the height function. Then, so what is the question? Then its velocity when it hits the ground is. So we want to find the velocity, not the average of the velocity. So now the question is, what will be its velocity? طبعا يا شباب, here, when the velocity here at the top, the velocity will be 0, but this is not our target now. طبعا here it will go back, and the question, what will be its velocity when it hits the ground? Okay, this is the question. So how to solve it? What we have, according to what we have before, we have that the velocity or the instantaneous velocity, it is the limit of this. So it will be the limit, the velocity will be the limit of the position function at a certain time, let's say at t2 minus y at t1 over t2 minus t1, or you can use t and t here because he used t. As we said, x and a, we used before x and a. So this is similar. When t goes to t1, you can use another definition, limit when h goes to 0. You can use it also. Now, the question is, what is this? What is a? What is t1? What is the time that we are talking about? What is the time that it will hit the ground at? So how to find that? So this is it is physical trick here. The question, Shabab, is what is the time here? Because I need time to talk about. So what will be the time at that point?
I
yes?
make the function equal to 0 to find the time.
Why? You put this equals to 0?
Because when it hits the ground, the position will be 0.
When it hits, this function is what, ya shabab? It is the height, صح ولا لا?
Yes.
What will be the height when it is on the ground, when the ball is on the ground? The height is 0. So to find out the position, of course, at that time, what you will do, you will put this equals to 0. By the way, what do you expect the velocity to be, Shabab? Positive or negative when it is going down?
Negative.
Negative.
Up to here, it will be positive. After that, it will be negative. When it is going to the maximum height and after that dropping down, it will be negative. So you have only 2 options. So these are not included. These are not options at all. So you have only 2 options. So now, as we said, ya shabab, before, you will put this equals to 0. Why? Because the height is 0 when the ball hits the ground. Now you will put it to 0, solve it, take t as a common factor. t equals to 0. This is the initial time. We don't want this. Of course, impossible that the time is 0. It spends sometimes. And this is the time that we are looking for. Now what you will do, you will go back here to take the limit, put t2 now, or t1, whatever, this one, put it equals to 100/49. Now here you will have what? You will have y at t2. Y at t2 is 0 because we put it 0. If you put this equals to 0, it will be 0. In that t, it will be 0. It is a matter of finding the limit now. Take t as a common factor, cancel with this, and simplify. You will have this, put t equals to 100/49. You have this again. As I said, ya shabab, before, you can do it, as I said, inshallah, we will do it next in the future using the derivatives. It will be very easy. Your y prime of t will be just 10 minus 49 over 10. T squared, it is 2. So this will be over 5 t. Okay? And you will substitute later by this. You will put it here. You will get the velocity. The velocity, it is the derivative of the position function. Okay, talking about the derivatives, we are not allowed to do this in this section, but here we have now the derivative, the initial definition, the formal definition of the derivative. The derivative is a limit. So this is why the limits are important. This is calculus. The calculus is all about derivatives, about limits. The derivative of a function f at a number a, denoted by f prime, we read it f prime of a. F prime of a is the limit of this difference quotient, of this average rate of change. If this limit exists, the derivative exists. If the limit does not exist, there is no derivative. There is another way to write this one, again by the same way. What you will do, you will put a plus h equals to x. This a, when x goes to a, h will goes to 0. So when h goes to 0, this will goes to a. X goes to a. You can use this form or this form for the definition of the derivative. Now we have a definition for the derivative, but it is still a limit. Find the derivative of this function at this number. طبعا in chapter 3, how to solve this, ya shabab, very easily. What it will be? It will be 2x minus a. F prime at a will be 2a minus 8. That's it. This is the answer. But now, if you have a written quiz, you have to do it using the limits, using the definition. I can ask you using the definition or using the limits. Again, you can do it easily. F of a plus h. Now, put instead of x, a plus h. Look. Instead of x, put a. Simplify using algebraic tricks, expand, cancel the like terms, combine them. Now take h as a common factor, cancel it. You have 2a plus h minus 8. When h goes to 0, this h will goes to 0, it will be 0, and you have at the end 2a minus 8, as expected, of course. Now notice, ya shabab, don't do this mistake in the exam, because I have noticed that many of you, they are not writing the limit. Don't forget to write the limit. If you write this without limit, it means that you take the limit. So if you don't write the limit, I will consider it 0 for you. You are not allowed to do this step. It is very important, ya shabab, to understand that you are understanding what you are doing. Now, look where we stopped writing the limit. We don't write the limit here because we evaluate it. We substitute. If you still write also the limit here, if you write the limit here until the end, I will consider it also wrong. Be careful, ya shabab. Now, you are not a middle school or high school student anymore. You have to do it. You are a university student. Why h approaching 0? Because this is the definition. Yeah, who is asking about this? This is the definition. Yeah, Mish'al. Why h is approaching 0? Because what is h? H, it is x minus a. When x approach a, when x goes to a, x minus a, when x goes to a, x minus a will goes where? Will goes to 0, which is h. This is h. I wish this answered your question. Is that clear, ya Mish'al? Okay, so the tangent line to a curve at a point is the derivative. It will be the derivative, clearly, because the same definition, if you notice. So instead of using the slope, if you remember, what was the equation of the point slope form? It was y minus y1 equals to m times x minus x1. This is the slope point or the point slope form for the equation of the line. Now, instead of the slope, we will write just the derivative. If you have the derivative at specific point A, so this x1, it is A, and y1, it will be f of A. Just like that. So this is the new formula. Just instead of the slope, we use the derivative. Let's apply it for this example. Find the equation, an equation for the tangent line for this parabola at this point. We have seen this before in the previous example. If you look, this is exactly the function that we have here. So we have the derivative. So we can now, if you remember, what was y prime? Y prime, it was 2x minus 8. Now at specific point, this is A, this is f of A. Now this is of course f of x. Now what will be f prime at A? What is f prime at 3? It will be 2 times 3, it will be 6, minus 8, it will be negative 2. So this is f prime at 3. And we can apply now this formula here. This instead of A, it is 3, 3, 3. Now here we will have y minus, what is f at 3? This is f at 3, equals to f prime at 3, it is negative 2, times x minus A, x minus 3. This is the equation. It is a matter of simplifying. It will be y plus 6 equals to negative x plus 6. This 6 will be cancelled with this 6, and you end up with y equals to negative 2x. So it is so easy now to find the equation of the tangent line, which will be, by the way, related to the derivative of the curve at that specific point. If you remember, I have defined the calculus for you in the first class to be the study of change, the mathematical study of change. So most of the subjects of calculus 1, math 101, it is about the rates of change. So we are studying the change in the position, the velocity, the acceleration, the whatever, any change, wherever you have change, you have the study of calculus. If you have a function of anything, whatever it is, if you have a function of 2 variables, one of them depends on the another one, then the change on the independent variable, we call it delta x, the capital delta from the small delta, the Greek letter delta. It is x2 minus x1. So it is the change on x, or the change in x. Similarly, we have the change on y, y2 minus y1. This is y1 to y1. Now, if you take the average, if you take the quotient of them, the ratio of them, you have what is called the average rate of change. So you averaging now the change between x and y, because y depends on x. So it will be delta y over delta x. And you know that this is, of course, the change of y with respect to x in that case, because y is the function here. If you take the limit of this average rate of change, if you take the limit when the delta x, when x2 goes to x1, or when delta x is 0, then that is called the instantaneous rate of change. Or just shortly, you can skip this word. You can just say the rate of change. So this is the average rate of change. This is the rate of change, which is the instantaneous, which means, of course, that is specific at a certain time or at a certain value for x, the instantaneous rate of change. So if you compare this with the definition of the derivative, you can see clearly that this is the derivative. So the instantaneous rate of change is the derivative of that function at that point. And also, if you relate that to the position function and the velocities, you can see clearly that the derivative of the position function, if this is the function f of t is the position function, its derivative is the instantaneous rate of change, which is of course when the change of position with time is the velocity at that particle. And I think also you know that the speed of a particle, it is the absolute value of the velocity, because the speed is always positive. It is about not about the displacement, it is about the total distance traveled. And this is an example or an old exam question that I want you to solve, Shabab. Please, I will give you 2 minutes to solve this. Try to solve this question in 2 minutes. And let me launch polls for you. So you can launch this polling. Yes, I did. So you can choose the right answer. Read the question carefully. If you want me to go back to the previous slides, I can go back. If you remember, it is about the rate of change. This is the rate of change, the average rate of change, and this is the rate of change. It is the limit. It is all about what we did before. There is no, I think it is not about the velocity. Yes, the cost in dollars of producing X units for a certain commodity is C of X equals. You have the function of change here, which is the cost function. The question is, what is the average rate of change with respect to X? What is the average rate of change in the production? When the production level is changed from X equals 10 to X equals 12. What is the average rate of change? Choose the right answer, Shabab, in the polls. Six students, mashallah. Could you please, ya Shabab, raise your hand? Please raise your hand. All of you, please raise your hand.
How can we raise our hand?
Go to the participants. In the participants, there is a hand there. Click on it. Go to participants, click on that hand, and you will raise your hand. Let me see who raised and who didn't. I'm still waiting for who is not raising his hand. All of you, Shabab, raise your hand, please. Abdurrahman Ali.
How can I even raise my hand?
Go to participants, and raise your hand. Click on participants, you can find your hands there. You have two hands indeed. Raise one of them. Ali Dawood, Ali Rafi, Muhammad Al-Khatib. Anyone who will not raise his hand is absent. This is the trick, by the way, of raising your hand. Okay, because some of you, they logged in, but they are sleeping. So it happens. Muhammad Al-Khatib, are you with us? Ali Dawood, section 27. Who is not raising his hand? Ali Dawood. Can you hear me يا علي؟ بعدين ما تيجي تقول لي أنت حاضر، أنت غائب يا علي. Ali Dawood is absent. Ali Rafi is absent also. We have two absent students. اسمعني يا علي يا علي. Okay.
Yes, here. Yes.
Thank you, Shabab. Lower your hand. Who is Ali talking? Ali Dawood.
Yes, sir.
وينك يا علي؟ وينك؟ Where is your hand? ليش ما رفعت يدك؟ Ali, why you didn't raise your hand? Ali Rafi, can you hear me, Ali? Ali Rafi is absent. I will do this يا شباب from time to time to check.
دكتور محمد خطيب سجلتني ولا رفعت يدي بس متأخر؟
علي الداود وعلي رافي. علي الداود كنت متأخر يا علي، وينك ما أدري. Okay, let me end this polling يا شباب. Okay, let me share with you the results. Now, 4 with A, 6 with B, 19 with C, 5 with D, 0 with E. And the answer is C. Excellent. Who solved يا شباب this question with C? Lower your hand يا شباب. Thank you. خلاص. It's okay. Lower your hands, please. Lower it by the same way that you raise it. The idea يا شباب is about, the question is about the average. So it is about the average rate of change. It is not about the rate of change. So the average rate of change, the average rate of change, I will not write all the statements. So the average rate of change, Shabab, will be what? Will be C of x2 minus C of x1 over x2 minus x1. There is no limit in the average rate. So what is x2 and x1? They are given, here they are. So it will be the value of the function at 12 minus the value of the function at 10 over 12 minus 10. What is an easy task? Now it comes to the calculator. You don't need a calculator. You have a calculator here. How to calculate this easily during the exam? You need to use algebra. So now C of 12, it is 4 plus 13 times 12, don't multiply, plus 12 squared, don't expand, minus C at 10. Both x equals to 10, it will be negative 4, negative 13 times 10, negative 10 squared. You can do it, of course, easily. Let me show you how to use algebra in this case. 12 minus 10, it is 2. So what I'm going to do, Shabab, 4 will be cancelled with 4. 13 times 12 minus 13 times 10 plus 12 squared minus 10 squared, all over 2. Okay, so these are all over 2. Now what I will do, 13 12 minus 13 10, I will take 13 as a common factor. It will be 13 of 12 minus 10. So I just took 3 as a common factor. Now plus, what is this? This is difference of squares. So it will be what? It will be 12 minus 10 times 12 plus 10. Just I'm showing you another way that you can, of course, skip the calculations. Now 12 minus 10, it will be what? It will be equals to 12 minus 10 it is 13 times 2 plus, this will be 2 times 22 over 2. Now this 2 and this 2, take it as a common factor and cancel it. You will have 13 plus 22, which will be 35. Look, we don't use any calculator. Of course, you can expand it and simplify it. It's okay. But of course, I believe that this is the best application for the algebraic techniques that you have studied before. Any question, Shabab, about this, please?
دكتور انا حليتها بطريقه.
You cannot use the derivative here, Shabab. You cannot use the derivative because there is no limit here. He is not asking about the derivative, the limit. These are the exercises, ya Shabab, that the suggested homework and the recitation. Please solve as many exercises as you can from your textbook. These questions, ya Shabab, you can find them also in 2.1. 2.1. I have repeated them here. By the way, in 2.1, this step is only from 2.1. These are 2.3. These steps and yes, I heard someone asking.
Yes, Doctor, the last question, I solve it, I substitute separately.
Using H or what? What do you mean substitute separately? What do you mean by that?
Go back to the slide, please. Yes, I put x equal to 10 and find the last solution, and also put 12 in the x and the last solution, and subtract them from each other over 2.
This is what we did. We subtracting them from each other. We divided by 2. It's the same.
Okay.
But you don't, ya shabab, like to follow the definitions. What we did, we followed the definition. Here it is. This is what we did. This is the average. Here it is. The average rate of change. Okay, you can here, shabab, see many old exam questions. It is a matter of evaluating the limits. Also, some of them is from 2.1. But of course, when you calculate the limits, this is not 2.1. When you have question like this, it is trivial. If you have question like this, ya shabab, in the exam and you didn't solve it, you will kill yourself. I'm sure about that. You will say, "Oh my God, how I lost this question." Who can tell me what is the right answer of this question? Is there a limit here? Let f be a continuous function of this interval, then this expression. Now, is there a limit here? في limit ولا ما فيش? There is no limit. So it will be slope, no. Of tangent, it could be slope of secant, by the way, but not for tangent. It could be derivative, no. Slope of tangent, no. So it could be average rate of average rate. It could be average because we don't have limit. So now what is it? Is it the average rate over this interval, over this interval? So this is the trick here, of course. He gave you this interval, but it is the large one. So if you compare it with the definition of the average rate of change, here it is. So what is x1 and x2? Here they are, 0.5 and 2.5. And the difference between them is 2. The difference between these two is 4. It is not 2. And the answer is E. Okay, Shabab, see you next class, inshallah. If you have any questions, I will be available during the office hours. If you have a question now, I can have 1 minute for you if you have any question. Class, يا شباب. Yes.
المعذرة دكتور، بس في البداية الاي دي ما طلع موجود عندك، بس انا في بداية الكورس سويت الصورة، ضغطت على العين وموجود، طلع موجود، وبرضه حطيت الصورة، بس فجأة قام يشيلها اوتوماتيك، ما ادري ليه، ولا البرنامج نفسه.
ما ادري يعني، انا لاحظت معظمكم الحين حاط الصورة يعني. This is good. This is what I told you to do. So please also I want all of you to do that. كمان اللي الشباب اللي هم they are hiding their emails, please I show you how to show it, not to hide it. And also